So 2/6 is about other types of equations. You might recall there was a few sections ago, I don't remember which section it was, where we just did like simple basic multi-step equations. But in 2/6, we're going to talk about radical equations, absolute value equations, some other types. So first, let's talk about radical equations. For a radical equations, you want to square both sides. But remember to use parentheses. If you don't use parentheses, if there's multi-terms on a side, you are going to mess up the process. So you want to square both sides, and my suggestion would be to use parentheses, okay? Now, our first example here, let's just take a look for a moment. You might notice that Alex says to give an answer that's a real number. So if we have an I as an answer, which we probably won't, but if we do, make sure that you write, oh, there's no solution to that one, okay? So for this one, just take your equation, surround both sides in parentheses, and in this one, it's just that numerical side, and there's not much there, so it's going to just work out okay. And solve it. So the square root and the square are going to cancel each other out. So that's just going to be v. And then 9 squared is just 9 times 9, or 81. Now here's where some things can go wrong. If we happen to have the square root of x equals -2, there's no real number that we could stick in there and get a negative, right? Now, if there was a negative sitting right here, that's a different story because we could divide both sides by -1. But this would be a no solution because there's no way that we could square root something and get a negative out on the real number line, okay? So just be careful how they ask the question. But basically here, just square both sides and you got it, okay? Everybody good with our first kind of little piece? Now let's start looking at some that are a little more complicated. So here you'll see how it says simplifies to one radical. So do you see this equation right here? Let me write it to the side like just a little bigger so you can see it. Before we can do what we did in the first one, you always have to isolate the radical. You want that radical to be completely on its own, okay? So in this case, we are going to have to move the 6 to the other side before we do anything else. So we would subtract 6, isolate the radical before we go to solve. Now, if we get to this point where the radical is equal to a negative, and they're looking for real numbers, we would say that there is no solution. Okay, but I want to do one where there is a solution, okay? So to do one that is a solution, let's rewrite this, and let's assume for a moment that the example was 4 plus the square root of w minus 5 equals 5. So what if it wasn't a 6, but what if it's a 4 instead? Well, when we go to subtract 4 from both sides, this time we get a positive value. Since we're getting a positive value, you can proceed without any issue. Just proceed along the same path that we did for the very first problem. We are going to get that radical by itself, which we did. We're going to surround both sides in parentheses, and to get rid of our square root, we're going to square both sides. Now this time, we get w minus 5 equals 1, If you add 5 to both sides, we get w equals 6. So it is a solution. There is a solution to that one. So if you isolate the radical and it equals a negative, no solution. If you isolate the radical and it equals a positive, then you're going to square both sides to find your solution. Are we good with those ones? Okay. Now these ones are a little more difficult, but not completely. As long as both sides are contained in the radical, if we do my trick where we are going to square both sides, so I'm going to write it over here. What happens when we square both sides is the radical pops off. So we get 5u plus 2 equals 3u plus 14. Now here's the problem with these. With problems like these, you must check your work in the original. Here's why. If we square both sides, we may unintentionally be making something that was a negative into a positive. And so it may not technically work, okay? So you might have to do some little trickery. And when you did that trickery, you screwed up the math. Not intentionally, it's just there's no other way to do it. So you have to check this in the original, not back in the this version. It might work in that version just fine, but you might have to check it back in the original. Okay, so let's just solve it. So you know how to solve these. This is the kind of problem I was talking about before. We know how to solve these. We're going to get the u's to one side. Let's subtract 3u from both sides. And then let's move the numbers to the other side. So let's subtract 2. So the numbers are on the right and the letters are on the left. It doesn't matter which, but this one works out good like that. What we get is 2u equals 12. And so u equals 6. Now don't just enter into Alex the number 6 until you have taken one little extra step to check it in the original problem, because it may not work. And that's what's wrong with these. So I'm going to write the original problem one more time. And I'm going to stick in 6. And I'm going to see, do I get a correct statement here? Well, 5 times 6 is 30. So that is 32. So that's the square root of 32. On the right side, 3 times 6 is 18. Plus 14 is 32. So only if they match, and there's not one that says positive 32 and another that says negative 32. Since they're match, then that is the correct solution. And you can do that step. You might, be able to do that step in your head. Oh, I got 32 over on that side. Oh, I got 32 on that side. They're both positive numbers. I can take the square root of those positive numbers. Because sometimes what you'll get is when you stick it back in the original, you might get a negative 32 equals a positive 32. And that's where it goes, wrong. So just be careful. Anytime you have a square root, it's a good idea to check the answer in the original. Does it work? And remember, a square root will never equal a negative. So if you get to the point where you get a problem like this, you would have to throw that solution out. Okay? Is everybody good with those ones? Okay, so those are your radical ones. Let's do one now where we have some pieces that are inside, some of our u's and pieces that are inside a radical, and some that are not. So that last equation, we had both pieces inside a radical. Well, you'll notice in this example, we have a u that's outside the radical. But if you do my trick, it'll work. So I'm going to write that over here. So the square root of 4u minus 3 equals u. Okay. Once the radical is completely alone, like it is, then we still do the trick, parentheses squared, parentheses squared. Now the reason we want to do it, like what if that side here said u minus 2? You would have to square it and then you would have to FOIL it. So Using parentheses will guide you in the right direction, so always use parentheses. Okay, now that we've done that, on the left side, the square root and the square are inverses. They're going to cancel each other out, and you just get the stuff inside. But on the right side, u squared is just u squared. Now, one of the things we have been looking at in 2.5, I think it was, we looked at quadratics. Quadratics can be solved by getting them equal to 0 and factoring. Usually, you might have to use a quadratic formula. I try to see where is my squared term going to stay positive when I solve a quadratic. So I'm going to leave this alone, but I'm going to take these and subtract them so that I can scooch them over. Okay, so let's go ahead and do that. So let's subtract a 4u from both sides. Let's add a 3 to both sides. Now when we do that, we get u squared minus 4u plus 3. Okay, now to solve any quadratic, you can use the quadratic formula. If it's factorable, that's my suggestion, factor it. So if you think about the factors of 3, they add up to 4, and that's why that's going to work, and that's a factorable quantity. There is a negative in both pieces. If the back is positive, just look to the middle. That sign is going to repeat in both quantities. And then this is a 3 and a 1. Now, you're not done until you have split it up one last time. Every factor could be the 0. So you get u minus 3 equals 0, or u minus 1 equals 0. And then, you can solve it. So we get positive 3 and positive 1. We're not done. You must check. You might get something called an erroneous solution. Now, erroneous solution means that the math you did is perfectly legit. Everything about it was wonderful and great. But when you went to plug it back into the original, it didn't work. So remember what our original is for a minute. Our original was the square root of 4u minus 3 equals u. Okay, so that's where we're going to check it. So if I plug in 3 to that original, I get the square root of 12 minus 3 equals 3. The square root of 9 does equal 3, so I'm going to circle that one. It works just fine. Okay, so that one, when I plug it in, I get a true statement. I get a, yeah, that's true. That's great. Okay, now let's plug in 1. I get the square root of 4 minus 3. Does that equal 1? Well, that's the square root of 1, which is 1. Now, there are times where you go to plug them back in and both of them fail this test. So you would say no solution. Sometimes when you go to plug it back in, one of them will work, but one of them won't. And then you'll go to plug them back in, like this one. Don't be fooled. The fact that both of them work, that doesn't always happen. So always take the time to just check it, whether you check it on in your head or with a calculator. Just make sure you check it. Any questions about that example? Are we okay with that one? Okay. Now, the last type of radical one that we're going to do is this one is a little more complicated than last, but we're going to use the same technique. So I'm going to write it right here to start with. Okay, and because that radical is completely by itself, I'm going to square both sides. The left side's going to keep its square, but the right side, the radical drops off. I'm still going to use the technique. Let's get the equation equal to 0 so that I can factor it. And if I can move everything where my v squared is positive, it just makes the factoring work nicer. So I just need to subtract off of v squared. And I get v squared plus 3v minus 10. Now what's great is, that's another factorable quantity. Again, If you don't see how it's factorable, feel free to use that quadratic formula. It's going to work. So negative b plus or minus the square root of b squared minus 4ac all over 2a is always an option for a quadratic if you don't see the factoring. But what are the factors of 10 that have a difference so you get 3 in that center? 5 and 2 is what we're going to go with. So let's go ahead and put that in there. So we said 5 and 2 have the difference of 3 we're looking for. If the back sign is negative, you always get a plus minus in those parentheses. Just look to the middle. Whatever the middle is, you're going to put that sign in front of the bigger number. So our bigger number is 5. The middle is a plus. So we want the plus to be on the 5 and the minus to be on the 2. We're not done. We still need to split it apart one last time. So v plus 5 equals 0. V minus 2 equals 0. So we get negative 5 and 2. Are we done? No, because maybe negative 5 works and 2 doesn't, or maybe they both work, or maybe they both don't. I don't know. You don't know until you plug it back into the original. Use parentheses. So let's do a little check. Now I'm going to do my check right underneath that square root right there, okay? So I'm going to plug in negative 5. Now it started out a negative equals. That's a really good chance that we're not going to get it to work, but let's check. 2 times negative 5 squared. Negative 5 squared is positive 25 times 2 is 50. I just don't have a lot of room, so I'm gonna I'm gonna do a little bit of math in my head here. 3 times negative 5 is negative 15 minus 10. If you do that math, you get 5. Is negative 5 equal to positive 5? Nope. So cross it out. Cross it out. Doesn't work. That is not one of the solutions that we can choose, okay? But if you didn't check it, you may not know that. Now, it doesn't mean, you know, sometimes a negative works just fine, but those are ones that are a little suspicious. Okay, now let's plug in 2. We get 2 equals the square root of, 2 squared is 4. You do the squared first, then you times it times 2. So 2 squared is 4 times 2 is 8. 2 times 3 is 6 minus 10. We get 14 plus, minus 10 is 4. The square root of that is 2. Yay. So circle that one. So the only answer you would enter into Alex is 2. Your math here is perfectly correct. It led us to 2 solutions. That's why it's called an erroneous solution. It may work, it may not. Always, always check an answer in a square root equation because it sometimes just does wonky things. Okay, so please check these or you're going to do them again and again in Alex, and you're going to get, your math is going to be beautiful and perfect. But if you don't check it back in the original, you're going to get it wrong. And on my test too, you're going to get it wrong because you have to check it, unfortunately. There's some things I go, you're probably okay. Checking isn't really super essential. For these, it's super essential. Any questions about our radicals before we talk about the very last thing today? Okay, so we've done radical equations. Now we need to talk about another form that's actually a radical hidden in plain sight. So here where it says rational exponents, let's talk for a moment about what that is. So I'm going to write just x, and I'm going to call it m over n. Okay. In a rational exponent, so a fraction is your exponent, this numerator is going to act like a power. The denominator acts like a radical. It is the index inside of our radical. So if we go to rewrite this, there's 2 ways you can write it. You can take the nth root of that number and then take it to the power. So you can do the radical first, and so that's your denominator, and then you can do the power. Or sometimes it's helpful to take the power first, and then whatever answer you get, take the radical. Now, the reason I tend to do this one first is the radical makes it little before the power will make it bigger. So I can usually do that in my head a little quicker. So let's say an example. If it is 25 to the 3/2 power, it's easier to take the square root of 25 and then cube it. And so the square root of 25 is 5, and 5 cubed is 125. If I went the other way, if I went 25 to the 3rd power, I don't know what that is off the top of my head. I would have to grab a calculator, and then whatever that answer is, take a square root. So the bottom of your fraction is the type of square root you have, the type of radical you have. If it's a 2, it's a square root. If it's a 3, it's a cube root. It's a 4, it's a 4th root, whatever it is. Your top of your fraction, bless you, your numerator is your power, okay? So if you look at our example down below here, so this is going to be our power. This is going to represent our type of radical. So it's a square root. Now with the square root, we don't usually write the index of 2. It is the most commonly used type of radical, so you don't have to put a little index of 2 there. You can. It doesn't hurt anything. So what we're going to do is we're going to take the square root of 16, get an answer, and then we're going to take that answer to a power of 3. So let me say it again. The bottom represents the kind of radical you do. The top represents the power, and you can do it in either order. It'll get you to the same place. I tend to, when I'm doing it myself, I usually do the radical first because it'll make it little, so then I can make it bigger again. So we're going to get 4 to the 3rd power. And then if I take 4 to the 3rd power, that's 4 times 4 times 4, or 64. Okay, so again, the 4 times 4 times 4. 4 times 4 times 4, 64. 4 times 4 times 4. Yep, 4 times 4 times 4. That's okay. Okay, so just remember, the bottom represents a radical. The top represents a power. I usually will do the type of radical first, get a small answer, so then I can take the power. You can do it either way. It doesn't matter, but that tends to kind of make it nice. Everybody good with that one? Now, let's look at how that appears inside of an equation. This technically is saying that the cube root of what number will give me -5. Now, if your radical has an index that is odd, you're allowed to take negative radical of, if it's like a 3rd index or a 4th or a 5th, 3rd or 5th or 7th or 9th. Because 3 negatives multiplied together give you a negative, right? So it's okay, it works. So negatives work, and we don't have to do anything special with a negative inside of a radical with an index of, like here, a 3. So what we're going to do is we're going to surround both sides. Just think about it. It's technically just a new way of writing a radical equation. We already solved those. We know how to solve those, okay? And what we're going to do is we're going to use the reciprocal to help us. Now, the reciprocal of fraction is just the flip of that fraction. So we're just going to take 1 over 3, and we're going to take it on the outside, and we're going to use 3 over 1. Well, what is really 3 over 1? It's just 3, right? 3 over 1 when you divide by 1 is just 3. Okay. So what we get here is that W is -5 to the 3rd. Now, you don't have to be quite as careful when calculating or checking a radical that has an odd index, because they just work so nice. -5 times -5 times -5 is -125. But let's just take a moment and do a little check so I can prove to you that it works. So if we take that answer to the power of 1/3, their claim is that we're getting a -5. Well, sure. The cube root of -125 is -5 because Negative 5 times negative 5 times negative 5 is negative 125. So it makes sense. So negatives that appear inside of a cube root, now they're gonna be just fine. But if it was a half power, if that was a 1/2 power, we could immediately go, no, that doesn't work. If it was a 1/4, 1/6, anything that was even will never equal a negative number. So be careful how you deal with those. You could have also, for this problem, rewrote that as the cubed root of w. If that helps your brain to understand it, you would take each side to the third power. So you get w equals negative 125. I mean, there's many ways to do a math problem. So if you like it in radical form, earlier we talked about how to do that. You could write it in radical form and then get rid of things. Or you can use the reciprocal power to get rid of things. It's really your call how you go about doing that. Are we good with that one? Okay. Now, what do we do when it isn't like that 1/3? You'll notice that this time we have a 3/2. So let me write it over here so we have a little bit of room so you can see it pretty good. So what you're going to do is you're going to put anything that is not in parentheses, put it in parentheses. And we are going to use the reciprocal power. What is the reciprocal of 3/2? You're going to take that 3/2, flip it over, and it's going to become 2/3. So the 3/2 power is going to become a 2/3 power. Now we're going to get z plus 10 equals negative 5 to the 2/3 power. Now let's deal with that for just a minute. Now remember, the top represents a power. The bottom represents what type of radical you have. So first, this is one of the very few cases that I'm going to do the power first. What is negative 5 squared? 25, right? The two negatives are going to make a positive. Negative 5 times negative 5 is positive 25. So would you guys agree that this is 25 to the 1/3? Now a 1/3 is a cube root. Now, last I checked, there's no way to take the cube root of a 25. It's not an exact cube root. What are cube roots? 2 cubed is 8. So 8 works really good inside of a cube root. 27 works good in a cube root. 64 works good. 125 works good. 25 doesn't. So you're just going to leave it. And you're going to subtract 10 from both sides. Now you can't subtract those two things because you don't have an exact answer for that cube root. So just leave it. And your answer is the cube root of 25, take away 10. Now let's go back and look at what it says. Do you see here how it says simplify your answer as much as possible? That means that's as far as we can go. So in Alex, there'll be a square root with, I think, like a little butt thing right there. And that means that's the one you're going to use. So in that little position, you can put a cube. Okay. So just so you know, that should be as far as you can go. Okay. Now let's do it again. We have one more of these. And we're going to subtract 4 from both sides. Okay, so we're going to stop. We're going to subtract 4 from both sides, and then since this has an odd denominator and this one's negative, we can keep going. It's okay. Everything's okay to keep going. And so to keep going, what's going to get rid of a 1/3 but a 3/1, which is just 3. So this goes in parentheses, and we put it to a power of 3. Now, that means that my 9v minus 1 is ready to go. And negative 4 cubed, you want to actually do that. Now, negative 4 cubed is negative 4 times negative 4 times negative 4. 3 negatives multiply and give us a negative. And then 4 times 4 times 4 is 64. Okay? So keep it in parentheses. And then do negative 4 times negative 4 times negative 4. And you can use a calculator. My suggestion would be put it in parentheses just so that things work out nicely. Okay? So we're going to add 1 to both sides. At this point, it's just a normal equation. We get 9v equals negative 63. So v equals negative 7. Now, cube roots, this is that 1/3. You don't usually have to check it a whole lot. They usually are going to work out just fine, but you could check it back in the original, and it would give you the cubed root of negative 64 equals negative 4. And then it would work out just fine. Okay. So now we're going to stop. We're going to continue this tomorrow. So we're going to stop right here. We're going to go down to the homework. And you are ready to try 1 through 8. So you are ready to try 1 through 8. So for the remainder of class, I want you to do 1 through 8. And then tomorrow we'll talk about absolute values. The next day we'll talk about inequalities. And then the next day we'll start talking about what the test is going to be. So we are finishing up the chapter, so that means that the chapter test is coming. So there you go. You work on that stuff. And if you have any questions, feel free to ask, and there you go.